JEE 2021 aspirants, how are you all? एग्जाम आने वाला है जनवरी में, क्या हाल चाल? Awesome, बढ़िया, मजेदार. Welcome to the session, guys. We are doing differentiability as of now, and I hope कि तुम अपने JEE 2021 के लिए बिल्कुल जी जान से लगे हुए हो यार. कितने बच्चे JEE 2021 के लिए जी जान से लगे हुए हैं? देखिए जरा in the chat box. Today we're going to be talking about differentiability in an interval. In the last class we have learned differentiability at a point, right? I hope सभी को differentiability at a point समझ में आ गया है. आज हम interval करेंगे. मेरा नाम है अरविंद सुथार. I have been teaching for the last 5 years and I have been constantly telling you what this 2 years, that is of class 11th and class 12th, gonna definitely gonna change your life. तो इसमें ज्यादा भटकना नहीं है, स्ट्रेट लाइन में ट्रैवल करते रहना है. This is the complete schedule which is being followed on the Vedantu JEE channel. Daily at 9 p.m. we guys are doing your classes of JEE 2021. Harsh sir is taking chemistry, Suri sir is taking physics, Arvind is taking your classes on Tuesday and Friday at 9 p.m. right? And apart from this, we are also taking some quizzes. If you haven't subscribed to the Vedantu JEE channel, do it now, because in 2019, out of the top 100 JEE advanced ranks in 2019, Vedantu has produced 7 ranks. Vedantu has taught over 9,61,000 happy students so far, and it has been an amazing journey so far. And if you are interested in learning live at Vedantu, go ahead with the pro subscription, because this pro subscription is available at very affordable prices. Number one. Number two, you can learn live from your home. Number one, you can be a part of live interactive classes with the best of the platform. You will get notes, assignments, test series, analysis, everything. That means you don't need to do anything else if you are taking this pro subscription, right? Yes. So if you are interested in this, 40,000 hours of live teaching, 20 plus master teachers teaching over there, 10,000 questions will be given, English or Hindi. You can choose your batch depending upon the language you want to learn in. Continuous areas, reviews of areas of improvement, micro and crash courses, all are available at this link. So go on to this link now. The 1 month subscription is available at 6,999 per month. 3 month subscription is available at 5,666 per month. 6 month subscription is available at 4,667 per month. But 12 month subscription is just available at 2,650 per month. If I would have been at your place, I would have definitely gone with this, because these offers come very, interesting offer, because if you use the coupon code ASPRO, you will get instantaneous discount of 4,769 rupees as well. So ultimately what has happened, this course is priced rupees 53,000, but if you use the coupon code ASPRO, what you need to pay is nothing but 2,729 only for the entire 12 months. Right? Go ahead with this subscription now if you guys are interested in learning live at Vedantu. We have learned about differentiability at a point in the last class. We have seen that if left hand derivative and right hand derivative both are equal, we say that the function is differentiable at that particular point. Yes or no? Left hand derivative, we have seen that it is written something like this. Left hand derivative is written like this, whereas right hand derivative is written something like this. We have already seen these things in the last class, right? If these two limits are equal, then we say that the function is differentiable or the graph is smooth. Let's say the first interval, let's say somebody is asking me, check your differentiability in this following interval, open A to open B. This means that between these two, if I talk about this interval means every point between A and B. So if your function is differentiable in every point between A and B, we will say that our function is differentiable in open interval A, B, right? डायरेक्ट है, हर एक पॉइंट में अगर डिफरेंशिएबल हुआ तो ओपन ए और ओपन बी के बीच में डिफरेंशिएबल हो जाएगा आपका फंक्शन. अगर वो closed interval देगा, if the question is given like this, it is talking about differentiability in the closed A comma closed B. The thing is, the function should be differentiable. The function should be differentiable in the open interval A to B, number one. The function should be right differentiable at the lower limit, because left hand derivative at x equal to a is not possible, because a is the minimum value at which you are checking your differentiability. So left hand differentiability is not possible, hence check only right differentiable at x equal to a. And when you look at this B is the rightmost point that is lying in the interval. That means on the right of B, no point is there, hence right hand derivability at x equal to B cannot be calculated. So you just need to calculate left hand derivability at x equal to B. If all these three things are happening, then we will say that at A comma B closed intervals, our function is differentiable or our graph is smooth. Let's have a look at this question. A function f of x is given to me as something like this. This min means minimum. Can you draw the graph of y equal to x and y equal to x square? If you draw the graph of y equal to x, your line will be coming something like this. Yes or no? This will be your y equal to x ka graph. If you talk about y equal to x square ka graph, your graph will be coming of such kind of a shape. Yes or no? Happy smiley wala, opening upwards. And this point over here is nothing but 1 comma 1. Yes or no? Yes. If we see, for x belonging to minus infinity to 0, for x belonging to minus infinity to 0, this red graph is lying below as compared to the black graph. For x belonging to minus infinity to 0, red graph is lying below black graph. Hence, red graph is giving us the minimum values. If I look at the values of x between 0 to 1, if I look at the values of x between 0 to 1, the black graph is lying below the red graph. Hence, black graph is giving me minimum values. And when I see for the x belonging to 1 to infinity, red graph is lying below black graph. Hence, this is the minimum value. That means what I'm trying to say over here is, if I draw my graph of y equal to f of x function, my graph will be looking how? My graph will be looking something like this. Yes or no? Everyone tell me. For the x belonging to minus infinity to 0, red graph is lying below, so I have taken the red graph. For x belonging to 0 to 1, black graph is lying below the red graph, so I have included the black graph. And for the x belonging to 1 to infinity, red graph is lying below black graph, hence I have included that. So can you say that your function, sorry, this is the function h of x, okay. Can you say your h of x is continuous for all values of x? Do you need to do you need to lift your pen up while drawing this particular graph? No. Hence, your graph of y equal to h of x is continuous for all values of x, because there is no break in the curve which I have shown in the figure. Option A is correct. If I look at this particular point, there is a sharp change, isn't it? In this particular part, the graph is of y equal to x, but the black graph is of y equal to x square. That means there is a sharp change occurring at x equal to 0, and there is again a sharp change at x equal to 1 because the function is changing its definition from y equal to x square to y equal to x. Hence, these are the two sharp points, and at sharp points the function is not differentiable. Hence, your function is non-differentiable, right? It is only continuous. So I think everybody is clear with this, that A is the correct answer. That means your function is continuous. Yeah, if you want to solve it algebraically, you can do it like this, but I think graphical way of doing this question is a lot more easier. Let's do this question. I need to find out or discuss the differentiability of this function. My expression is given to me like this. You might have learned that if you draw a number line and if you plot the x at which this expression is getting 0, this will be x equal to 0, and the value of x at which x minus 1 modulus is getting 0 is 0 and 1 over here will come. Now, for all the values of x greater than 1, mod x and mod of x minus 1 will both be opened with a plus sign. For the values between 0 to 1, mod x will be opened with a plus sign, but mod of x minus 1 will be opened with a minus sign because the thing written inside the modulus will become negative. And for the values between minus infinity to 0, your expression will be always what? Your expression will be always opened with a negative sign. So in this case, you can write down your expression like this. Both the modulus opened with a negative sign. In this particular region, you can open your first modulus with a plus sign, whereas second modulus with a minus sign. And in this third expansion, you can open your modulus with both the positive signs. So here it is coming y equal to minus 2x plus 1. Here it is coming y equal to 1, and here it is coming 2x minus 1. Can you draw the graphs of these three functions, and can you see at how many points sharp function is coming? Wherever the sharp function is coming, your function will not be differentiable. So let's draw all these points. Whenever x is negative, I think this will be your graph formed. This is 0, 1. This line is y equal to minus 2x plus 1. Try to draw this graph. Okay. When you talk about between 0 to 1, your graph will be formed of this shape. I'm drawing it by a black because, yeah, this will be the shape. And then whenever x is greater than 1, the shape of the graph will be something like this. Can you see that at this point and at this point, there are sharp points coming? If there are sharp points coming, can you guys see that at these 2 points, your function will be non-differentiable? Because our function is differentiable wherever sharp points are there. So these 2 points, x equal to 0 and x equal to 1, are the 2 points where your function is coming out to be non-differentiable. So graphs help a lot in calculus. As I told you in the very beginning of your class 2021 sessions, I have taken 3 sessions specifically for the graph, so that when you find such kind of questions coming in front of you, you can kill such kind of questions instantaneously, right? Yes, also I would like to tell you one thing. Non-differentiable function plus differentiable function will always be a non-differentiable function only. So when you look at this expression is differentiable, not differentiable at x equal to 1, whereas this is a differentiable at x equal to 1. Try to draw the graph of y equal to mod x. X will come 1 over here. So y equal to mod x is definitely differentiable at this point, and y equal to mod x minus 1 ka graph will come something like this, which is definitely not differentiable at x equal to 1. So definitely the combination of these two will be not differentiable at x equal to 1, and similarly the combination of these two will not differentiable at x equal to 0. This is another way to do the same problem, right? Moving ahead. Yeah, let's try to do this problem. I have taught you that limits is class 1, continuity is class 2, and differentiability is class 3. If you pass your class 1, then only you can enter into class 2. So if limit is satisfied, then only you will check for continuity. If you have passed class 2, then only you will come into class 3. That means if continuity is existing, then only you will check for differentiability. I hope that you guys have watched my previous version on differentiability where I have discussed these things. Yes, so I need to check the differentiability of this particular expression such that the differentiability is that if the function is differentiable at x equal to 1, then I need to find out the value of b and c. So I can definitely say that my function is continuous at x equal to 1. If your function is continuous at x equal to 1, then f of 1 should be equal to left hand limit at x equal to 1 and right hand limit at x equal to 1. Yes, your right hand limit at x equal to 1 is coming out to be b plus c plus 1. Your right hand limit will be written by this particular expression. So when you put x equal to 1 into this, you will get it as what? You will get it as 1 plus b plus c. Your f of 1 will be written from this particular thing, and your left hand limit will also be written from the same expression. So you can see that your b plus c is nothing but 0. Why? Because if your function is differentiable given, then by default your function should be continuous. By default your function should be continuous. Let's talk about the differentiability. If we talk about the differentiability, if we write down f dash of x, for x lesser than 1, you can differentiate this one easily because this is a polynomial expression, so 1 will come. And if you differentiable the second expression, differentiate, your expression is coming out like this. Now observe one thing very carefully. Here I have not applied xk equal to 1. Why? Because there is the definition changing of the function, and whenever the definition changes, you need to separately check for the differentiability. So for x lesser than 1, don't worry, your function is differentiable. For x greater than 1, don't worry, your function is differentiable because this is a quadratic expression and quadratic expressions are always differentiable. But wherever the definition of the function is changing, you cannot be sure about the differentiability. So I am not gonna apply this equality symbol over here. If your function is differentiable, your left hand derivative at x equal to 1 should be equal to right hand derivative at x equal to 1. So left hand derivative will be written from this, so this is 1, and your right hand derivative will be written from this, that is 2 plus b. Yes or no? You can get the value of b from here very easily. B is coming out to be minus 1. If your b is coming out to be minus 1, can you put this into this equation and can you find out the value of c? Yes, c is coming out to be 1. So what are the values of b and c coming respectively? Minus 1 and 1 respectively. Minus 1 and 1 respectively. Easy question. Again, I will summarize this. If your function is given differentiable, by default it has to be continuous. So one relation you have got in terms of b and c from the continuity relation, and second, the differentiability thing, any polynomial is always continuous and differentiable. So we were not worried about x and x square plus bx plus c ka differentiability. We were only concerned about wherever the definition is changing of the particular function and the definition is changing at x equal to 1. Hence at x equal to 1 we can equate left hand derivative and right hand derivative because the function is given differentiable to us. With this we can easily get the value of b. Once we got the value of b, we can easily get the value of c easily, and -1 and 1 are coming the values of b and c respectively. All right, yes, let's try to solve this problem. If your function is given differentiable, is given continuous but not differentiable at x equal to 0. If your function is given continuous at x equal to 0, you can say that your f of 0, your left hand limit at x equal to 0 and your right hand limit at x equal to 0 should be equal. Then only your function will be continuous. So your f of 0 is given to your 0, and LHL and RHL are definitely same, I guess. So we can write down what? We can write down limit x tending to 0, x to the power a into sine of 1 by x. Now if x is moving towards 0, 1 by x will be moving towards infinity or minus infinity depending upon x is positive or negative. If x is positive, that means if x is 0.000000001, you're going to get 1 by x as infinity, and if x is minus 0.0000001, you're going to get 1 by x as minus infinity. And sine of infinity and minus infinity is always unpredictable. You don't know the value. Sine of infinity and sine of minus infinity, nobody can tell us, but we know that it will be some unique value between -1 to 1. At least we know that this value will be lying between -1 to 1. Yes or no, everyone tell me. If I want, if I know that this particular thing over here is going towards 0, so can we somehow calculate the value of a? Just try to think, everyone. I'm giving this part as homework because I want you guys to put your brains now into this. I have already explained a big part of this as hint so that you guys can put your brain into this question and try this question because this is really a good one. Okay, moving ahead. Your function f of x is given to you as something like this, and it is asking you where between 0 to 2 is your function non-differentiable. We know that this expression is non-differentiable at x equal to 1 by 2. This is differentiable at x equal to 1 by 2, and this is also differentiable at x equal to 1 by 2. So differentiable plus non-differentiable will be what? As I told you, it will be non-differentiable. Hence your function is non-differentiable at x equal to 1 by 2. Similarly, the second expression is going to be non-differentiable at x equal to 1. Rest both of these going to be differentiable. Hence your overall expression is going to be non-differentiable, and this expression is going to be non-differentiable at x equal to pi by 2. Yes or no? Because at x equal to pi by 2, tan x is not even continuous. This one. And if a function is not continuous, it can never be differentiable. Pi by 2 is nothing but 1.57 something, which is definitely lying between 0 to 2. Hence, these are the 3 points at which your entire f of x cannot be differentiable. That is at x equal to 1 by 2, x equal to 1, and x equal to pi by 2. Right? Yes. Moving ahead. If you are interested in learning live at Vedantu, then I would like to tell you that in the year 2019, Vedantu has produced 7 ranks in the top 100 JEE advanced rank list. You can be the next. If you want to be a part of this great initiative, go through this pro subscription in which live interactive classes, assignments and notes, test series and analysis, All this is available for you people. 40,000 hours of live teaching, 20 plus master teachers teaching you over there, 10,000 questions in the forms of test and assignment. English or Hindi, you can choose your batch in whichever language you want to learn. Continuous reviews or your areas of improvement, micro and crash courses all are available in this pro subscription. Go on to this link now, and the more lengthier day duration of subscription you take, the more costlier, the more cheaper it will become for you, right? Yes, but whatever course you take, don't forget to use the coupon code ASPRO before making the payment, because if you use this coupon code ASPRO, you're gonna get discount in your course price. And if you take a 12-month course, instead of paying 31799, you only need to pay 27029 if you apply the coupon code ASPRO. So instead of 53,000, you guys can have the entire JEE course for JEE 2021 at just rupees 27,029. So what are you waiting for? Go ahead with this. The guys who can't afford this, join our Vedantu Telegram group, because there we upload assignments, notes, daily updates. This is the link. Join this Telegram group now. If you learned something from this video, don't forget to hit the like button, share across your friends, and subscribe to the Vedantu JEE channel, because here we, the team of IITians, are working day in and day out so that we guys can make your dreams into a reality, and we are working constantly for that. Keep learning, keep shining, keep smiling, keep rocking, keep working hard, because the efforts that you're gonna make today are gonna change your future. See you in the next session. Bye bye. Take care. Love you all.